Chapter 10, number 45. The minute and hour hands of a clock have a common axis of rotation and equal mass. The minute hand is long, thin, and uniform. The hour hand is short, thick, and uniform. Is the moment of inertia of the minute hand greater than, less than, or equal to the moment of inertia of the hour hand? Choose the best explanation. So if we sort of sketch these very quickly, we have the minute hand is long, thin, and uniform, and then the hour hand is short, thick, and uniform. Something like that. But they're each rotating sort of about their end. They should be overlapped, but then the picture would be kind of confusing. Anyway, we can see that on average, the average mass is further out in the blue case. In other words, this distance is more than that distance. And so the typical mass is further out. And we remember that the moment of inertia is some number essentially times the mass times the distance squared. And so since the masses are going to be the same, but the average mass is further out, the minute hand wins, as it were. So the minute hand, right? The minute hand has a greater moment of inertia, and that's explanation 2.